started. And please feel free to unmute yourself or ask questions. Then I'm looking at the Jupyter Lab in here, or I'm unable to see Teams. I see Teams, but I might not pay attention if you ask a question. Okay, Bismillah. Last time we covered pandas. Pandas is a package in Python that we can use it for reading and manipulating data. It's very similar to R language data frame. R language is very common in life sciences. Now, what we will do today, inshallah, we will be continue learning more about pandas. And pandas would be one of the main tools that we will use during this class. So we'll try to cover it, even though if it might take even a longer time than other topics. And I already posted a link for another YouTube video I recorded in the past for pandas. It does include a lot of details. Best I was explaining that class, if I remember, was local version of Python on the local computer. In here, we are using Colab. So for Colab, there are a few changes that you need to do to get to load your files, for example, and this is what I have done in here. To load your files, first and foremost on Pandas, I uploaded I do have a folder on my OneDrive. It's called Farm 6 to 15. And I do have a subfolder called example 01 underscore 01. And the data file that I have is dataset underscore 01. It's a CSV file, comma separated file. It's like Excel sheet, but it's more of a text file. Now, if you wanted to get started and load all of your information from this file or the data from this file, and this is what you guys will do. You'll be collecting your data, saving all of your data within Excel sheet. And you can either read the Excel sheet in here or you can read it as a CSV file. If you have an Excel sheet, you can go to File, Save As, and save it as CSV file if you wish. Otherwise, you can go with Excel sheet and read it as an Excel sheet. Now, the difference between CSV, why I prefer CSV, because CSV is a text-based one. Two, it doesn't have a limit. Like if you work with Excel, there is a limit number of rows. And if you have a huge data, large data, Excel might not be able to handle the huge data. Okay, so the very first thing that you will do is you import pandas, you import OS, and this OS is for manipulating and reading the contents of a specific file and folder. And the next line is what you see in here, this selected line. It's drive.mount and content drive. So this one you need to do it one time. Every time you run your Colab, you need, do you see my screen, guys? Is my screen visible? Okay, let me just stop sharing and sharing it, because sometimes what happens when I refresh my browser, okay, perfect. When I refresh my browser, it stops sharing. Okay, so what I have is I imported pandas OS, and then in here I imported from Google .colab import drive, and then I call this function drive.mount, and you need to use the same thing that I dropped in here, content drive. And now you specify where is your file. So this one be exactly the same. This component that I'm selecting, highlighting it here will be the same for all of you. But what will be changed is the folder where you include your files. In my example, I use farm 615, and there is a subfolder called example underscore 01, and this is my file. If you have it at your local computer, for example, you might have it on your local computer. So if the file path will be equals, so you have it at C colon documents highlight, and the file will be dataset underscore 01.csv. So this is in case you have it on local computer. If you are using Unix, but if you are using Windows, the backslash will be the other one, this one. And so I'm using just a single backslash. To make sure I am safe, I can add just R in here. So this will be on my local computer if you are working on your local computer. But if I'm using it on the cloud, I'll just use it like this on Google Drive and Colab. Now, once I run this one, you need to run this line only one time. So let me just show you what will happen if I run it multiple times. I'll just push this to the top. I do have this mount, and like I already ran it before the class, so it will give me an error now. It will tell me that the drive is already mounted at this place. So this will create an error. If you do not have it, so you will not have this error. So you need to run it only one time. So just put it, and this is why you have seen I made it as a comment. Now, okay, I removed this. I don't have any issues. I ran it for the first time. It's already mounted, available for me. Now I just need to specify this is the file path, and this is the full path where my file is located at. Now I just use the variable called file name. So I just use file name in here instead. And like we will use something called try catch, try except. This try except is just exception handling. It will try to read my file. To read my file, I'm using pd dot read underscore csv, and then I'll provide my file name. And let me just remove this piece. I was just testing this before the class just to make sure everything is up and running. And now it was able to read my file successfully. If I did not mount my file, or let's say I'm just using an incorrect file name, I run it, it will tell me that the file could not found. The system was not able to find my file, and that's due to using incorrect name. Now it's able to read my file, everything is good. Let's just see what do we have in the file. So data frame dot head, it's easier just to read the first 5 or 10 rows. So it tells me that this is patient ID, MRN. We have first name, last name, sex, date of birth, age of like years, marital status, marriage, divorce, single. We have ethnicity, preferred language. So we do have a lot of information. Remember last time we wanted to see what information we have and get more information about our file. So we use describe, and describe will tell us we have age, we have zip code, we have height in centimeters, weight in kilograms. So it provides me with more information about my data. And BMI, body mass index, those in milligram, refill count. So we do have a lot of information about this patient. I think we have 50 some, I do not know how much we have. So let's see how many rows and columns we have within this data frame. So remember we used shape, and shape provides us how much data we have within our data frame. Now, just a disclaimer, this data is not real. This data, I downloaded this data from ChatGPT. I asked ChatGPT to synthesize some data for me. And the data that has been synthesized, I asked it for some clinical data with some pharmacy or medication information. Now, let's see the shape. Remember that we used print, and you can just say the shape and print the shape. It tells me that the shape of this is 500 rows, and we have 52 columns. If you wanted to see what columns we have, let's just do print. And I wanted to see the data frame dot, like the columns, I can go and retrieve columns, and dot last time we talked about to list, which will convert everything to a list. Now this will list what columns I have. You see them in here, and they are easy to read, like MRNI, first name, last name, sex, that date of birth, age. Also, what you can do is you can use a for loop if you would like to, if you wanted to print it using a for loop, I can say a for an item, just any variable name, and df dot columns. So this is columns, and I can say just to print an item. So what it will do, it will take every single like entry within my data, within the columns, and then it will print it in here. Now you can see uh, the columns one by one. Okay, so what happens sometimes, and just be careful about this, if you do have a lot of entries, if you try to print all of the contents, your uh, Jupyter Lab might freeze. So I'll just make it as a comment. I do not want to see all of them, but let's see the data types. We will print, and we have a data frame dot d types. And this will tell me what are the data types that we have within our data. And like most of them, they are objects because I did not convert them. So therefore, um, we need to convert them to the proper data type. We will see this in a minute. So we do not need this one anymore. Let's see something else. Now, we read the file. Let's try to select a specific columns from our data set. So I will just call it review. And in this review, what I will do, I'll just, instead of using everything, I'll be just selecting a few columns. So let's look at, for example, let's see what we have. We will start select patient ID. I do not want to use all of them. So I want to use just some of them. I will separate them by comma. You can have them at the same line, but for me, it's for simplicity and ease of use. It's easier if I just put each one and read it easier if I have each one at a separate row. So I'll go with a patient ID. I'll get the age. Let's get also the sex of the patient. Sorry, I told you just be consistent. It's fine if you use double or single and mix them, but I wanted to be consistent. And remember, if I wanted a subset, we use the double, the two double, the brackets, two brackets. Let's see what else we have. Let's get with the primary diagnosis, and I'll copy it. And what else? Let's see. We have medication one. We have, uh, okay, let's go with it. Dose in milligram. Let's go with, so we have a lot of, also a lot of vitals, blood tests, and let's see. I remember like when I was preparing for this one, I had something about, uh, it was, I think, uh, HbA1c underscore percent. And I had creatinine in milligram. Okay. So I tried to diversify the data. So we do have different data types of uh, from this data. Now let's look at preview or review. So review, and it will print me the data. Now I do have, if I want to look at the data shape, you can see I selected 500 by 8. So I selected 8 columns. Let's look at the top, like 10 rows. So I'll go with review, and we can just say head. If I use head on its own, it will provide me with the top 5, but I wanted to see the top 10, so I can just provide 10. Tells me that there are patient IDs with different ages, different sex, with different primary diagnostic, medication, dose in milligram, HbAc1 percentage, and creatinine in milligram. Let's try to find certain patients. If you remember last time we tried to filter, we applied some filters, and the filters that we applied, we used the greater than, less than. Uh, so let's just say we're trying to find high uh, blood pressure patients. So I'll go with the data frame itself. If you remember, we do have systolic and diastolic BPP, blood pressure. So I'll just filter those patients and retrieve them. Uh, so I'll go the data frame itself. Remember that we can just do dot, and if I go with dot, it will tell me exactly what's the entry. So this is the systolic BP. I like to go with the square parentheses because if you have spaces within the name, it's easier for you to retrieve them. So let's say if it's above 140, print it. But this might not be enough. So what we will do is we will go and just say at the same time. So we'll use the and say that if the diastolic is above 90, or we can say, or the DF, let's just open parentheses and close it. And as you can see, when I open a parentheses, I close it so I do not forget to close it. And sorry. Okay. So now I filtered all of these patients with this uh, high blood pressure. Now, I wanted to see for those patients in specific, I do not want to print everything. I wanted to see, for example, their ID and their blood pressure in general. So I can just say, print me those patients. Let's do print. So I wanted to print those patients and I just wanted to see the patient ID. And I wanted to see this noise and I want to see. So this way, instead of scrolling into 52 different columns, I can just look at uh, specific columns. So I'm looking at the data frame in here. So it's giving me an error because I did not close the parentheses in here. Now I can see all of the patients with this information. I have 3 columns. I can sort them. I can play with them, and I can see how many of them with high blood pressure. So let's see. I do have just the ones that I selected. It seems they are uh, all of them. They have. So I have a logical error in here. I did not say that they are above 90. So I'm looking for anyone with this above 140 data frame. Okay, I may have overwritten the data frame itself. And data frame is correct. And high BP, let me just see what I have. Okay, it seems that I do not have patients with this. Oh, I see. Okay, so I do have a few issues in here. So this is the open and the close. This is the open and the close. This is the open and the close. This is the open and close. Okay, now it's correct. Okay, so you can see we have 173 patients with the systolic is above 140 or the diastolic is above 90. So in this case, I'm just showing those patients' IDs and you can just print all of the patients with a for loop. Now let's try to count how many patients with each value. So what I will do is I already declared this high BP, high blood pressure. And what I wanted to do is I wanted to see how many, or let's just go with the data frame itself. I know within the full data frame, you remember that we have a primary diagnosis. So let's look at the primary diagnosis that we have and how many diagnoses we have, primary diagnosis we have. Now I do have 500 patients, but I do not know what are the counts of each diagnosis. Like for example, if you have a list of patients and your patients, you have diabetes patients, you have patients with high blood pressure, you have people with chronic kidney disease, you wanted to find the frequency of each value. So what I can do is I can select this column, and there is a function called value counts. This value counts will find me for each one of them how many patients I have. Like for this, for example, each one, pneumonia, we have 34, asthma, we have 33, migraine, we have 30, and so on and so forth. So it will tell me how many patients of each type I have. Now I can just save it into count equals this, and I can go and print this count. So now I do have more information about my data. Remember that when we talked about the data, we mentioned that sometimes I need like specific count of data, frequency, if I want to train a machine learning model. So this will tell me a simple statistics about my data. Frequency, I can draw a histogram. We'll see it in a minute how you can create a plot out of this data. Now, the other thing is, like within our data itself, sometimes what happens is I go to the hospital, I ask for data, and they provide me with data with some missing information. For certain patients, they did not make readings or they did not record some specific information. So I wanted to find this missing information, and missing data uh, is a challenge in our case. So what we'll do is we will just do missing summary, and we will open the data frame itself, and then we will see is an A. Now, is an A will return true or false. So it will return true or false. And if I use it now, it will just print a list of true or false. False, that means it's not missing. True, that means it's missing. Now, if I just do dot sum, any true will be equals to 1. So it will count how many missing values I have per column. Now, it's telling me patient ID is all available. 0, that means nothing is missing. Alcoholic use, it tells me that 106 patients are having missing information. Secondary diagnosis, it says that I do have 29 patients. They do not have a secondary diagnosis. Allergies, 176. Now, it's very hard to go and read this. It's not sorted because a lot of zeros. So what I will do is I will go and sort it by the number of missing data. So dot sum, it tells me how many missing data points that I have. So I'll go and just use sort values and sort it descending. So ascending, تصاعدي, false, that means I'll just go and sort it tenazuli, start from the beginning. So I have allergies at the top. I have 176 from the top bottom. Alcohol use, I have 106 patients. I do have HbA1c percentage. I have 35 patients with missing information. Now, this will help me, for example, do quick analysis on the data. For instance, I have allergy 176. That tells me that, so what's the percentage in here? To do the percentage, I can just go and do len, divide it on len of the data frame, and this will give me a percentage. I can multiply it by 100%, and this will tell me what's the percentage of missing data. In some cases, when I deal with data, it's good to see what's the percentage. So I have 35% of the missing data. So the best solution in this case, either to exclude those patients or exclude this column if it's useless. Alcohol use, we have 21%. 4, 7, 6, and below. So what I can do is I can just impute these data points. So I can retrieve them, predict what the missing values based on the context, and fill them up. Now we identified what missing data we have. So you can process that. Um, let's see. So what I wanted to do in the next, I wanted to find out the patients where I have, they have specific creatinine, for example. If the creatinine is above 1.3 and the EGFR is less than 60, that means they have high risk. So let's try to create a filter for this. Now we read our data. Our data is still valid. I'm trying to check. Okay, everything is good. I did not override it. And what we will do is we will create a new column within our data. Now, if you wanted to create a new column, you can just use df, open square parentheses, and create a new column and just, let's just call it renal risk flag, and I can assign it to 0. Now, if you try to print df, you will see that there will be a new column. Tells me they are 53. The new column will be appended at the end. Let me scroll all the way to the right. Yeah, this is the new column. Now, what I wanted to do, I do not want to just save 0. I wanted to create uh, sort of condition. This condition is something similar to if else. Now you can see what has happened is Colab is providing me with suggestion. I'm not going with the suggestion that Colab is providing me with. I will use NumPy. Remember, NumPy is a package that we talked about in the past. It's not included, so I need to import NumPy as NP. And we can use this with math, with matrices. And in this case, what I will use a function called where from NumPy. And this where function, I wanted to apply specific condition. I will say if the EGFR is less than 60 or the creatinine milligram is above 1.3, that means it's a high risk. Otherwise, it will be a low risk. So how do I do this? We will open parentheses, and we will set the first condition. We said the first condition is we are looking for a column, this column. So like, how do I get this help? I hold control and then I press space bar, المسطرة. Control المسطرة, it will show me the suggestion. If it's less than 60, or this symbol is called pipe. This pipe, it means or, and I'm looking for, again, I will open close parentheses, DF, and I'm looking for the creatinine. So I just type 1 or 2 letters and it provide me with the correct letters, and it's above 1.3. If this is valid, we will fill a value. The value that we will fill it in here, that it will be high risk. So just call it high risk. And otherwise, if none of these values is valid, we will just call it lower risk. Now I run my code. If I go all the way to the right, I should be able to see the new column, and the new column has been filled with high risk and low risk. Now, I do not want to see everything. I wanted to verify that all of my information is valid. The information that I filled up is valid. So what I will do is I'll just do print, or I like to go with a data frame without a print. And I would like to use the same uh, 3 columns that I printed in here. So I would like to print them all so I can see if my assumption is valid and my code is good. So I'll just take the 3 names, the 3 columns. I will retrieve them and print them. So remember, this will not print them. So what I need to do is I need to enclose them between these square parentheses. And you can now go and verify the high risk based on the condition I set. I see some 3 dots in here. If you wanted to see all of the data, you can just use print. It doesn't show me all of the data. I can do print. I think I can click on this piece and it will show me all of my data in the form of a table. So you can see all of the data. I don't know how many rows I have, but it will show me all of the rows that I have. I can go next, 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 and see everything within the data, verify that my equations are all good. Okay, so now we have applied a condition. We have filtered. So this is type of filter, the where. So it's filtering part of my data based on specific condition in one line, and how we can create a new column and assign it with a new value. Now, there is also some sort of aggregation. The aggregation that we have is I would like to group some data, and grouping this data based on specific values. So I can find mean, standard deviation, I can sort the values, I can round them. So let's see what we can do. The first thing that I would like to do is creating a group. So group by. So let's just go with our data frame. I always like to check my data frame is not deleted, so I still have the same data. Now the group by is dot group by, and group by, you can create a group or find a certain aggregation. Group by can find you sum, total, average, count, based on specific condition. So what I will do is I will find a group by the primary diagnostic. If you remember, we have primary diagnostic, and tells me select the primary group by primary diagnostic and find the average of the age. I do not want to find the average of the age. I would like to find the HbA1c percent, creatinine, and BMI. Let's just delete this mean. So now grouping by the primary diagnostic, it will find me in here, and then it will use the columns that I will specify now. Now open and close any parentheses that you open it, and I'll go with HbA1c percentage, and I will also like to have the creatinine. It's creatinine. Milligram underscore, I think it was DL. If I wanted to verify that I'm still on the right track, I can just print it. Okay, this is good. And the last one, I wanted to extract, if you remember, we have BMI. So I do have the three variables in here. And now the aggregation is based on, it will go and find me all of the patients that they do have anxiety, and then it will find all of their HbA1c and creatinine and BMI and find the average for them. To go and find me all of those patients with asthma, find me the mean, and so on and so forth. So to go and aggregate based on the patient primary diagnosis, and then it will aggregate all of these patients by the mean, the average. Now, now the values in here, they are huge. I don't like to have these like 6, 7 precision. So I would like to round it. So you can just do round, and it will take all of these values and just trim them. It will be just 2 digits to the right of the decimal point. Now we round this. I don't like to look at it. This one doesn't make sense. So I need to sort it in any like a certain way. So let's sort by this HbA1c percent. So you can just say sort values. Sorry. So we are looking for sort values. And let's say we are sorting by HbA1c percent ascending. So I'm starting from the greatest to the lowest, the least. Let's say I wanted to look at the BMI. I can just do BMI. So I sorted them now by the BMI. So this is the BMI. I started with 30.71, and I started, this means descending. So if I want to sort them from smallest to largest, I can just set this to true, and the smallest BMI is 26. Let's save this. Let's just call it summary in a variable, and now we can just print this summary. Writing, okay. So this is the summary, is printed. You can save it, you can export it to Excel, you can plot it, you can draw it, you can do anything with this data. Now, what you see so far, what I've been doing, I've been creating individual cells. Now, like I like to go with cells like this. So this is one cell. Once you are done with a specific cell, what you can do is you can combine all of the code. So this one I need it, so I can just copy or cut this one and put it with the previous cell until I end up with a full code. Okay, now let's look at more aggregation. So what I will do is I will create a new, this is called add table, a new aggregation. And in this aggregation, I will start with data frame. So what I will aggregate, I will apply group by the same, df dot group by. But this time we'll group by different columns. So I'll group by primary diagnosis and medication adherence. So, and you can see, you can apply on any primary, on any columns. Yeah, so I need to, if you see in the previous case, I just aggregated group by primary diagnosis. So I just enclosed it between double quotation. But how about if I wanted to aggregate by group by multiple columns? If you aggregate by multiple columns, you need to use square parentheses, square brackets. So I'll go primary diagnostic, and maybe we can go with, um, I think we have medication adherence. Okay, so medication adherence. And now my group by, it will find the size. So I'll just find the size of it, dot size, and let's see what size will provide us with. Now, the size that I will have, I need to unstack it. That means you are flattening it. So unstack is another function that you can use, size dot unstack. And this one, fill values. If a value is not there, it will fill it up with 0. So unstack and fill it with 0. And then sort by, like for example, let's sort it by the index. Now let's print the 8 table. And you can see this is what we have. We have the medication adherence. It does have primary diagnostic. Medication adherence, if you remember, it was, what are the values of medication adherence? I don't know what is it. So let me just print it quickly. I can just do df medication adherence. Okay, so it was high, low, medium, etc. I know what is it exactly now. Can just delete this one. So I went with the primary diagnostic, and then I aggregated by the adherence, and then I calculated the size. So you can see now it appears before I unstack it. Anxiety, I have high, low, medium. How many patients are high? 16. How many low? 3. How many medium are 7? So it have done it for all of them. All of my medications was aggregating first by the primary diagnostic and the adherence. Let's just try to do it the other way around. I wanted to go and start with the adherence and then aggregate based on the primary. So it will find me high, low, and medium. And for each one, high, what are the primary diagnostics? And then what's the count? I mean, it doesn't look nice. So what I will do is I will just put it first, the primary diagnostic, the medication. And now you can see it appears as 3 columns. Now, reading this with Python is tough, is hard, it's not easy. So what I will do is I will apply unstack, and anything that is missing that doesn't have a value, like for example, in anxiety, let's see, if I have, let's say in migraine, low, I don't have any patients. So it will appear and it will be 0. After that, I will sort them by the index, and I will show the table. And this is what has happened. Now you can see we do have the medication. We have 3 columns, high, low, and medium. And we displayed the values in the form of a table. And this is much easier to read as in Python. Now, that takes me to one other example. There is something that we call it in statistics in Excel and in Python. We call it pivot table. Pivot table, that means you are creating some statistics about your data, and this is statistics in the form of a pivot table. So we will go with the data frame that we have, and we'll create a pivot table. This pivot table will create a compact summary for exploring data. So it's very useful for exploratory analysis and creating dashboards. To create this pivot table, let me just make sure my data frame is still intact. Everything is good in my data frame. If you feel like your data frame may have changed, you can read the file again, read the CSV file. But in my case, I'm not going to read it because it's still everything is good. So we will use pivot table. A pivot table comes from PD, which is pandas. Pandas dot pivot table. And in the pivot table, so what I will do is I will just call it pivot summary, and I will print my uh, pivot summary in here. Now it's still empty, nothing in here. So we'll start this pivot table. I will start with the data frame, which is my data frame, and the pivot table. So what will happen is it will provide me with index and list of columns, similar to what we have done in the top one, which is um, medication adherence and the primary diagnostic, but it will be much more of a summary. I started with the data frame that I will use for my pivot table. And what do I need the values to be? So the values that are within the body of my table. So what I will do, I'll just do something similar to the blood pressure that we have done, which we have used, I think it was systolic, yeah, blood pressure. And the second value was systolic blood pressure. Now, these are the values. We will see them in a minute where they will appear. They will appear in the body of the main email. And now the index that I will use, I'll just differentiate them by the sex, the gender. And what are the columns? So you specify what are the indices, which is the x-axis. What are the columns? So in my case, the columns that I will include, I do have smoker status. So smoker status. And the aggregation function, remember the aggregation function, you can use either single aggregation function or you can use multiple aggregation function. In my case, I'll be just using the mean. Medium doesn't make sense in my case. So it will be aggregation function. If you use multiple, you can use a close them between square parentheses. And now, we do have multiple parameters, but I wanted to round these values. Remember, round, it will remove the decimal places. Run it. Now we can see this is the pivot table. It tells me this is the diastolic and this is the systolic. We do have the smoker status, current, former, and never. And the systolic BP, do we have current, former, and never? We do this in male and female. For example, in female, diastolic, for those who are current smokers, it's 75, and for male is 78. For former smokers, it's 81 and 76. So I can read something. They never smoke, it's higher. And the female is lower. Is female always, on most of the cases, is much lower, except for the current smokers. For the female, the systolic is always less for a smoker, former smoker is higher, and never smoked is much high. For the male, it's higher, the current, so it's the same pattern. So you can see in here, just by creating this simple pivot table, I can just read a few readings. I can read things. Now, what you see in here, uh, like Google Colab is providing me with some suggestions. It tells me generate code with pivot summary. So I don't know what code it will generate. So it tells me that you can generate anything, provide prompt. I'm not interested in this as now, but you can use it for printing things. Now, what I would like to do in the next exercise, let's assume that you have a data of 1 million entries and you would like to see patients with a specific information. So for instance, I wanted to find all patients who are taking medication one or medication two as metformin. So what I will do is I will just say data frame, and my data frame. Remember that we can use parentheses, and it tells me in here automatically. It gave me some hints. I do not want to use this age. What I would wanted to do is I wanted to find those patients with medication one and medication two. If it equals, I must use double equals sign, two equals sign without a space between them. And we wanted to use metformin, or they have medication too as metformin. So I will use or in between them, and I'm missing in here a parenthesis. So this is parentheses, data frame, and metformin. Mm, I'm not sure. Okay, I am missing. Okay, double quotation in here. Now you can see how many patients are taking metformin as medication one or medication two. I do see that there are 36 patients, but let's see. I wanted to see their information, those 36. I do not want to see all of this information, so I'll just set it in a variable. Let's just call it metformin patients equals this data frame. And by the way, I can just put everything in here in one line, but it might not look nice. So it's easier to read if you have it in multiple lines. Now, what I will do is I'll just take this matrix that I created, and then I would like to see the patient ID, and I would like to see their primary diagnostic. I know that they have these medication. I wanted to see if their second drug is metformin, what's the first one? And if it's the second one is metformin, I want to see what's the first one. Also, I would like to see what's their problem, what's their primary diagnosis. And I would like to see, for example, how about their uh, HB, uh, HbA1c percent. Okay, let's look at it. I think I see a lot of patients in here. So I wanted to know how many do we have there. So you can just do count. It will tell me that you have of each, I have 36 patients in here. And what I wanted to do is just, I wanted to see head of 20. Let's just look at the top 20. Okay, so I can look at it. If you would like to sort it in a specific way, so I can just go and do sort, dot sort, underscore values. So what do you want to sort them by? So you can specify I wanted to sort them by their primary diagnostic. Okay, so I do see the patients with anxiety who are taking metformin at the top. And I can also see how many patients I have in total. So you can just say this is summary. And for this summary, you can print the summary. Okay, sorry, it's a data frame. So this is the summary. You can also print how many we have. So just use print. And this will tell me how many we have of each patients. It's not count. I can also see how many using length. So I can see count and we can see the length. It tells me that I have 20 patients with the first medication or the second medication is metformin. Any questions so far? So you guys able to read the same Colab Jupyter Notebook? Okay. So the next one is I would like to find out who are the patients who might need a closer follow-up. For example, I would look at their HbA1c. I will look at their blood pressure. I will look at the EGFR. And if any of these patients have specific uh, values, they must have follow-up. So I'll call them follow-up uh, follow-up patients again. So what I will do is I'll create data frame, and this data frame will include some conditions. And let's just put these conditions on separate lines. So the first condition that I will look at, I would look at the um, HbA1c, and I would say if this is above 8.0, or they have what else? It tells me creatinine, but I would like to look at the systolic. And if it's above, let's say, if it's above 150, greater than or equals 150, or if my patient has, like, let's say, the EGFR milligram is less than 45. So what I will do is I wanted to see all of these patients. Now let's just try to find some information about those patients. Okay, so how many patients? I have 132 different patients. Let's select certain columns for those patients. So I will select, I'll just call it columns. And the columns that I will select for those patients, I'll create an array. And this array, I would like to get the patient ID. What else? I would like to get their primary diagnostic, for instance, primary diagnosis. And let's try to find also the HbA1c, the systolic, the EFGR, and I think they do have next follow-up date. Let's just hit this one, next follow-up date. Okay, now I would like to select those patients with all of this information. So I do have the columns. Now, since I do have, this is a list column, so I just need to use one square parentheses so I can see all of those patients. What I would like to see is I would like to sort them by or prioritize them. So I'll just apply sort value. Now we learned for sort value, you can provide one value or you can provide multiple values. So to provide a single value, you can just provide it like this. If we have, now it's sorting by HbA1c. If I want to provide, if I wanted to sort first by HbA1c, and I do have those patients is the same, I wanted to select a second criteria for those who have the same value as HbA1c. Now to do that, I'll go and sort by the systolic, for example. If I feel the systolic BP is the second priority, so I'll just sort by the systolic. Now, if I display the data, I should be able to see that the HbA1c has been sorted, and within this HbA1c, they started sorting descending. If you wanted to specify ascending or descending, and you can show like the top, let's say 20. And this is exactly what we have. So we are looking for HbA1c. They are sorted by HbA1c. And if there are multiple values with the same value, they will be sorting at the systolic blood pressure. Okay. Now let's try to create some plots. Visualization. Visualization are important. So what I need to do is I have a package. It's called Matplotlib. Let me try to see if it's available. Matplotlib. And if I don't have it, I need to install it with pip. So you can do pip install matplotlib. And remember that if I wanted to install it, I need to start it with this exclamation mark. Now, since we do have it, I'll just remove this one. I'll just put it as a comment. I executed this cell, and since I executed it, I can read it and it did not throw any errors. That means the package is available. Now, what I would like to plot, I would like to plot a few information, like for example, let's look at the age in years and try to plot it with see how many patients we have, sort of the histogram, distribution of age. Now, we do have the same data frame. What we have done, we imported Matplotlib. From Matplotlib, we imported PyPlot, and we call it PLT. So we'll use this PLT. You can name it whatever you want. We'll just call it figure. So this figure, you can specify the size of this figure. 10 by 6, I can specify it 8 by 5. Let's just say it's 8 by 5. When I display it, I execute it, nothing will show. If you wanted to show the plot, you can use plot.show. So I'll just put plot.show. And since my plot's still empty, nothing will happen. So in between, I would like to create these plots. Now, plots, you can do it in two ways. The first one is you can use Matplotlib on its own and use plotting to plot it, or you can use the plot from within pandas. And this is what we will do. I will go to the data frame, and from the data frame itself, I will use the age. Remember that we have age in years, and I will use plot. Now, the plot that I will create, there is one variable in here. It's called kind. What type of plot you wanted to create? So in here, it tells me that these are the types of the plots that I have. It's kind. The kinds can be line chart, it can be bar chart, it can be bar H, it can be histogram, box plot, KDE, density, area, pie, scatter, H-bin. So these are the options that I can provide with this kind. In my case, I'll just use histogram. Just a simple histogram. It's HIST, histogram. And then the histogram itself, how many bins do you want? How many columns you want? So I'll keep the bins, like for example, we can keep them 20. Color sky blue if you wanted to have them. Edge color is black. You can remove. These two are optional. But if you wanted to change them, you can change them. Immediately showed me that the title age distribution of patient age, and let's just plot it. Now you can see this is my distribution of ages. Tells me that this is the x-axis and the y-axis. The frequency is the y-axis and the x-axis is the age, but it's not clear. So it's a good idea all the time whenever you are creating the plot to create label. So I'll use PLT X label, age in years, and plot Y label is frequency. So instead of frequency, we'll just call it number of patients. And do you want to show a grid? Like you'll see the lines. So I said yes, true. And now you can see the plot. Let's just remove this grid. I think there is one PLT dot type layout. So type layout, it will make a good layout. Now you can see this is distribution of patients' ages. Let's say pharmacy over class 615, distribution of, so you can include whatever you want in the title. Now the x-axis says age in years, and the y-axis says number of patients. This is the bins. If you calculate the bins, we have 20. If I would like to see more details, instead of 20, I can just say, let's just show me 50. Now it tells me more details. Seems our data starting from 18 up to 100. So let's just make the, so from 20 to 100, we are talking about around 60. So the 60 bins, now I have more details, and you can see either you can make them 5 if you wanted the distribution to be tight, and this is 5. Between 20, like between 18 and 32, how many patients you have, how many 40, or you can make it larger by including, like, let's say 25. So these are the 25. Now, with this diagram, or if you want like to save it, you can just save as an image, and you can save it and use it if you would like to. Now, there are many other tools that you can use for example, saving or creating plots. Let's see one more plot. So the following plot, what it will do is it will show me, let's look at the primary diagnosis. So what I will do is I'll create PLT again. So this is another plot. And this plot, what I will do is before I create the plot, I will create counts. And this counts is the primary diagnostic counts, value counts. Remember, let's just print it just to make sure that we know what we are working with. So it will tell me how many primary diagnostic I have and what are the plots that I have. Immediately, uh, Colab is suggesting you can use counts.plot. So remember that counts is the data frame that we created out of this value count. So I can just go and just say counts plot kind. It's a bar chart and the color is sky blue, or you can just use red or whatever color you want. But before we go there, we would like to create the plot. So I created the plot, and the plot is a figure of size 10 by 5. And now I created the plot. Now let's just add plot title, the primary diagnostic count, and the x-axis will be the diagnosis, and the y-axis is not count exactly, it's number of patients. Okay, so I do have number of patients, and the y label is number of patients. If we would like to have the ticks, which is these tick marks, where do you would like to have them? I would like to rotate them 45 degrees. And which direction? I would like to have them to the right, tight layout, similar to what we have done. And then I have show. Let's see what we get. And this is exactly what we have. So remember that we said we named our chart as diagnosis count. We have the x-axis, it was diagnosis, the y-axis number of patients, and we do have the bins. We decided how many bins to use. We decided we wanted to use, we did not specify how many bins because each bin will be a diagnostic. So the diagnosis that we have, this is why we did not specify any bins. Now, the y-axis was the count. You can sort, and they already sorted by default. Now, the rotation in here, which is how you would like to have this. Having it more rotated, it will just save us some space in here. So if you are writing a thesis or you are writing a report, you want to include some images, the rotation will help you just make it more readable rather than just having it horizontal. What else? Yeah. So if you don't like this one, let's just say green. You can specify whatever color you like. And this will be the green color. Or if you would like to get the theme that we have within VS Code, is actually blue, so you can just keep it there. Are they the only parameters? No, there are more parameters. So if you just click, for example, a spacebar, it will provide you with more. And you can go to Matplotlib on the internet online and just um, search for the this type of plot and see what other options we have. Let's see one more plot. In this plot, what I will do, I will create a scatter plot. So scatter plot is very important to show data points with X and Y axis. So my X and Y axis will be the systolic and diastolic. So let's just try to create a plot. So we'll have our plot. Let's just say we have plot dot figure. We'll specify the size. Now, the plot that we'll create, it will be plt.scatter plot. So it will be scatter. And as it's here, it means it's saying we are looking for uh, systolic and diastolic, and let's just say plt dot show. Remember, this is what will show our plot. So this is our plot. It still doesn't have any options, doesn't have anything. So I like to go with green rather than purple. So you can see it in green. Now let's specify some information. So for example, I wanted to specify plot dot title. Okay, diastolic versus systolic. Let's provide the x-axis and y-axis. And let's grid. I do not want to see the grid. I wanted to see instead create tight layout. And now we can see this is not plot quickly. If you want to create it in Excel, it might take you like 5 minutes, but within Python, you can see in 30 seconds, we created everything. So this is the systolic blood pressure, and this is the systolic. We do have the title, we do have the tick marks, and we do have now the distribution. If I look at this, mainly what I can read in here, so this is the center of everything. There is a pattern in here. It tells me that those might be blood pressure. So those people with systolic is very low and their diastolic is very high. So you can also go and create it versus age. And let's see, for example, I would like to create more of analysis. The analysis that we'll create, we will look at let's look at one more chart. So this chart, we'll just get the average, HB A1C, and this average is, we'll just create a group. For example, my group by will be the primary diagnosis, and we will look at the mean. Okay, and we are rounding by 2, and let's sort the values, and ascending equals false. Okay, now I do not want to print this one, or we can just look at what data we have created. Okay, so I do have averages, perfect. Now, what I will do is I'll create a plot, and the plot has, let's just show the plot, dot show. Now the plot is empty, nothing is showing in here. Within this plot, what we will do is we will show the average, and we will show it in a plot. The plot kind will be a bar chart, and the color, whatever you like, is green. Now you can see we do have the diagnosis and we have the HbA1c. Now let's just modify it. We'll just uh, modify the plot. We'll create a title. We'll create x-axis. This is average. Okay, take the rotation. You can see in here, I did not create any rotation. It looks ugly, so I will just make it as 45. And to the right, if it's in Arabic, if it's بالعربي, you can make it in left, and I'll create a tight. Let's see. Okay, this is all good. Maybe what we can do also, let's look at the, okay, we created the tick, we rotated the tick, we made it and tightly out. Okay, I think I showed this multiple times. Okay, perfect. So I think this is a huge, let's just make it 8 by 6 so I can see it in one screen. So you can see I can play with the size, this size. I can make it 6 by 4. So I can see it smaller, or you can make it larger. I think this is very small. Yeah, and at the end of the day, you can, I think, right click on it and open new page, and you should be able to read it much better. Let's show one more example. In this example, what I will show is admission date. Let's just use date and time. And this is important example. So if I look at the data frame, my data frame, and I look at admission, there is something called admission date. Admission date. Now, if I just see, it's not Is it admission date? Admission date. Let me just look within the DF. Dot columns. Okay. I can do find search at admission. Okay, I do have admission last 12 months, I think. Let's just look at it quickly. Okay, okay, this tells me that if they have been admitted in the past, I want to see something as date. What do I have as date? Okay, let's go with last visit. I want something at date and time. So if I go with last date and we try to look at it, it tells me that if I try to sort it, this is text. So let's just see the types. Tells me this is an object. Sorry, the type. I can just type. I forgot what was the type. Describe. Okay, so this is a type. The type is objects, not date and time. So what does that mean? Let me just do sort values, and sort values. I have just this. So let me just sort all of these values. So if you look at the sort in here, is not sorting in a like it's 15, 14, 13, 26. Now it's ascending. So the sort might not happen as I wish it happens. Why? Because this is an object. So what I need to do is I need to convert this into a date and time so it make more sense. To convert it to a date and time, what I will do is I will override it. Now, immediately, Python expected what I'm planning to do is I wanted to convert it to a date and time. So I used pandas, pd dot to date and time, and then I provided the same column. Now, when I provided the same column, let's just go to the same thing. If you remember the very first time that we printed the type describe, it was telling me uh, it was an object. Now I have it as still an object, but it's providing me with more date and time. So I do have minimum, maximum. Unlike what we had before, it was just looking at it as just a regular object. Now I have it as a date and time, and I can use it to uh, in mathematical logical operations. Like I can add one day and time. I can do more of statistics on and plot, in fact. So let's see how many months I have. So I'll just do monthly count. So I'm looking at the last visit or admission date. So monthly counts, let's see, the last visit. Now I'm looking at DT. This DT, it will give me the date out of this date, the full date, and I can convert it to specific periods. The periods in here I can provide with months, days, weeks, I can years, whatever data I have, then I will have the size. Let me just print it so you can see what I have. Now, these are the last visits. I took the year, it will take the year and convert all of the months. Even if there is a month that doesn't exist, it will go and add it and it will fill it up with 0. So I started from January 2024 up to March 2026. So this month is the last month that we have. Now I created this. Why do I need this? Because I wanted to use it as an index for my chart. So monthly count. Now monthly counts, let's just set the index dot index, which is the index that will be used for the chart. So it will be monthly counts index to uh, either I do not want to use it as a timestamp. I wanted to use it as a string because I wanted to show it on the chart as type. Now I will just show it as a string, as a character. Now print it. You can see the last visit is that it's the index and it's a string. So I can use it as an index for my plot. Now let's create a figure. So my plot will be plt dot figure. The size is just make it 8 by 6. The monthly count plot, let's just show it as line chart. I'll show a line chart instead of plot. And the marker, there is something called marker, which is the shapes that we are showing, markers, equals, for example, I will just use the O's. And let's just do plot dot show. So you can see I'm showing the minimal. Okay, monthly plot dot plot kind equals line, and the marker is plot. Kind is line, monthly counts. So I have monthly counts, it's a data frame, monthly counts index as type string. Then I created the plot and I'm showing the plot. Okay, markers. Okay. I do not know why it's giving me markers. It's marker. So you can see in here, these are the markers that I have. These are the dots. So I can just change it to plus, I think. You can see it's changing to plus. I can just have it as a star. It's a star. Let's just keep it all. Okay, so now you can see this is a line chart. And this line chart, I think it's big a little bit. Maybe I can just zoom out. And the x-axis will be the month. And we do have the y-axis is the frequency. So how much I have. I think we are calculating how many visits we have, people visiting us. Now let's create a title for our plot. So title will be monthly patients. The x-axis label is the months, and the y-axis is the number of admissions. Let's just call it not number of patients. A patient might be admission multiple times during the month. And now if I try to do it, you can see these are still ugly. Maybe we can do the rotation and make it a tight layout and display it again. So this will look like much better now. So what we have seen in here, I use date and time as part of my plot, and this plot is showing a line chart. Okay, well, let's see a different type of plot. So there is a type of plot, it's called box plot. The box plot is a box that shows some statistics about your data. So let's just create a data. Our data will be the data frame. Let's just create the data frame. And I would like to look at the body mass index of specific patients, but I wanted to find those body mass index and I wanted to show them with the sex. So I just create them by gender. So what I will do, I'll start by looking at the all patients who have a specific category, and then I will find them unique. So I'll start by 4. This 4, I'll just call it category for each category and the data frame. And I'm looking at the sex in the data frame. Now, sometimes what happens is just print it, category. Now, it would print me male and female, but how about I do not want to look at all of them? I want to look at frame and female and male, but how about if there are some missing? To remove the missing values, you can just say drop NA. Drop NA means remove anything that's with missing values. I just wanted to see males and females. I do not want to see NA. Now, it was repeated. I just wanted to see a unique list. So you can just say dot unique. And now I do see male and female. I do not see anything that's with missing values. Now, I'm looking now at the male and female, and let's assume we have anything else. So this is why I wanted to use a for loop. And this within this for loop, I do not want just to print it. I wanted to go and use this for loop within a data frame. And this data frame, I will go and look at the data frame, and there is something called location.lock. This will, we will provide within this is either a true or false value, which is an index for a data frame. Now I wanted to say this location. So for this location, use the data frame, and I wanted to see the sex. And within this sex, I wanted to see if it equals the category, which is recreated below. So this is the category in here. I'm using it in here for everyone in the category. Do I need to return just the category? No, I wanted to return the category and the body mass index that I have within my data frame. Now, do I need everything? Yes, but I do want to drop anything that's an A, not available. And now for each one of this, just retrieve this information. Now I do not need this. So this will return every single value within the male and female that are unique and it doesn't have any missing values. And so just let's make sure that I have the same category in here. And this will be if the data frame, the location of the sex equals the category, and I wanted to return the body mass index. So this will return all of the male and female. It will drop anything that's not available, and it will iterate over everything. And this will be uh, a data. So this will be my data. And I have a data frame in here. I do have this. Now this for loop will go in here and I need to close my data. Okay, let's see the data. What are the contents of data? So you can see in here within my data, I'm looking at whatever like the sex is, and I'm looking at the body mass index of every single patient within my patients. And what we need to do with this data, we will assign it and make it as, we will assign labels to it. So labels in this case, so we do have the data and we wanted to create labels, and the labels will be the sex. And we will make sure that we do not want to include anything that's the sex is missing. So I'll just go with drop NA. And I wanted to look at the unique values. I do not want to look at all of the values. Now we know within sex, we do have, it's either true or male or female. Okay, so I do have the data now. I created the data. I created the labels. Now what we will do is we will create a plot. Remember that this PLT, I already imported it at the top from matplotlib.plot. So I'm still using the same one. It's highly recommended whenever you are creating plots to include it at the, like at the beginning of your plot. So you don't, like your model is not confused. So we have PLT or your Jupyter notebook. Now we created the plot. We'll just show the plot. Now the plot is still empty. Now what we will do is we said we wanted to create a box plot. So our box plot, it's box plot. And then I provide it with the data. And there are labels. Labels equals the labels that I created. Sorry. So I do have the labels equals the labels that I have. Now it will create a box plot for me, one for male and one for female, and the actual values would be the BMI. The BMI, the body mass index of the data. Now it's giving me that labels parameter plus has been renamed to tick labels. Okay, it seems that in Matplotlib 3.9, which is the version that we have in this Python, labels has a different name. So it says tick labels, so which is fine. I just used it. And this is now the box plot. The box plot tells me that there are some outlier data in here. These data points are out of the range. This is most of your data. The body mass index for the males are around 30. And for females, it's a little bit less than that. And the maximum value. So we call these ones as whiskers. زي الويسكرز اللي شوارب البسة بنسميه whiskers. So these are the whiskers. This is the range of the data. This is outliers. This is outliers. And this is the main distribution of my data. I think you guys already have had box plot within the biostat. Now the PLT, let's just create body mass index distributed by sex. And we have the sex, we have the body mass index, and we will create just the type layout. And this is our box plot. So the box plot, as we said, it will show us just a quick some information about our data. Let's see a distribution of our data. Let's see one more example. And this example, what we will do is we will show a pie chart. So remember the adherence count that we have used before. So adherence count, it was the medication adherence value counts. So it was DF of medication adherence, and we have seen it as value counts. Let's create a plot dot figure plt dot figure, and our figure is just make it. So what we will do is we'll create a plot, and in our plot dot. So we are creating a pie chart. The pie chart will have the adherent count, and the labels will be the adherent count index. And let's just look at the percentage, which will be the actual values. So what we will do is we will just show it in a specific percentage, auto percent. Let's just show it as 1.1 F. And I do not want these ones. So these are just some other prompts. I'll just keep them as comments for you guys. You can put them up and look them up. And let's just do plot.show and see what we get. So this is a pie chart. I do have the medication adherence. We are looking at the value counts, how many they have high, how many they have low, how much percentage we have for medium. Let's just add a title in here. So plt dot title, medication adherence, and let's just make it tightly out. So this is the pie chart of our data. So you can see a percentage per level. What else? We have seen a scatter plot, but we can look at one more scatter plot that will show us the, for example, the creatinine versus the EGFR. So let's just create one more plot in here. So I do have plt dot figure, and the figure size is 8 by 6. And let's just create a plot dot scatter plot. And now I will be looking at creatinine milligram. And let's look at DFAGR and alpha equals color gradient 0.7. And let's look at the title. Let's just use the title creatinine versus just at the title. Sorry, plt.show. Okay, so this is my, it's complaining because you wanted to provide a title. So the title that I have is creatinine versus EGFR. Okay, so this is my scatter plot. My x-axis is creatinine and milligram and EFGR and tightly out. And now you can see the scatter plot. Now I do have the x-axis, the y-axis. It takes the ticker in here is taking what we have identified in the dataset itself. Any questions? Any questions?